So artificial intelligence has become in the mainstream. About 2 years ago or so, with the introduction of ChatGPT, everybody started to learn what AI was about. We acquired a company called Virtual Control a few years ago to bring in AI ML capability into Agilent. Our first product was a phthalates application with GCMS, and what it does, it was able to use AI and ML to do peak integration. And where you asked me where it makes the biggest impact is to save the user time in the data analysis. So if you think about an AI ML model that could be trained with hundreds or thousands, maybe tens of thousands of analysis of everything a laboratory might see, this is good, this is bad, and everything in between. They could train an AI model to then be able to have it given samples that are running in the future and be able to have automatic data analysis and peak integration identification that significantly shortens the user's time that it would take to do that analysis. So a big play for AI is going to be in increasing the throughput and the shorter time to get an answer and increase productivity. So those people in the laboratory don't have to spend that time in front of a computer, so they can be spending more valuable time in whatever their lab or their enterprise requires them to do.
AI, machine learning, has become more and more important. And there are different ways to apply machine learning or AI. So there's one way to apply it in a way where you use machine learning, AI, to monitor instruments and the health of an instrument. So to become better in predicting when it needs maintenance, how the performance is tracking over time. And there you can use, and we do apply already, machine learning and AI technology. There's another part which is also getting more and more important, is with the amount of samples we run on an Orbitrap Astral Zoom platform, for example, with the amount of data generated, how do we make sure that we get all this data processed and analyzed in a way that it makes sense? And there AI and machine learning will play a role. We have implemented, as part of a collaboration in the Proteome Discoverer platform, algorithms like Inferis, Chimeris, where it's all about machine learning and AI to make a better use of the data we generate with our instruments. And this will continue in the future as part of our developments.
Even though the mass spec data is highly informative, there's also a lot of artifacts in the data that one have to exclude, right? So having a system that, certainly AI, that will allow you to help you make those decisions on the fly as well, and communicate with the instrumentation as to, hey, this is the next experiment that you have to do, for example, right? Being able to interpret the data as well and connect the two together, data processing, data acquisition together. I think that, again, it goes with the whole realm of throughput, speed to data, and being able to make decisions on the fly, essentially. That's where I think that AI, and also from the point of view of, models, right, building models for different organisms, different cell types, for example, that you have a deep phenotypic characterization, and start to use those models to build even more predictive model that will lead to better therapies in the future. That's where the power of AI does come in general. So I think that, just to summarize it, I think it is, as I see it, is around the instrument acquisition and setup, and also from the data processing side, right? We need to get those two together, and then networking with other data inputs as well.